Dr. Xi, please take the floor.
Thanks very much for invitation. Honorable Chairman, Mr. Ishizuka, distinguished delegates, ladies and gentlemen, it's my great honor to be here and share with you about the developments of DC transmission and distribution technology in China. I'm Mingming from State Grid Corporation of China. My report contains 6 parts. Firstly, let me give a brief introduction about our corporation, SGCC. State Grid Corporation of China established in December 29, 2002. State Grid supplies power to over 1.1 billion population in 26 provinces, autonomous regions, and municipalities, covering over 88% of Chinese national territory. And now SGCC has achieved the 2nd place on the Fortune 500 ranks. The ranking rose from 7th to 2nd. State Grid takes investment, constructions, and operation power grid as core business. The annual electricity sales achieved 3,874 terawatt hours. The annual profits of the corporation are $91 billion. The total length of the transmission line achieved 987 millimeters. Here gives some company operational data. The total employee of our corporation achieved 1.6 million employees. The total investment in fixed assets achieved 506 RMB. The transformation and converting capacity achieved 4,350 gigawatt ampere. The reliability of urban power supplies and the reliability of rural power supplies are given respectively. The line loss of transmission line, the average line loss achieved 6.66%. Here gives a brief introduction about organization structures of SGCC. The headquarters of SGCC has 30 offices. It contains administration office, a general office, strategy research office, and so on. And it also has 27 provincial subsidiaries. It contains Beijing, Tianjin, Hebei. So the states of China, there's 27 provincial subsidiaries, and it also has 6 branches, which is separated in North China branch, East China branch, Central China branch, Northeast China branch, and Northwest China branch, and Southwest China branch. Besides, there's also 38 other subsidiaries directly managed by State Grid. Here gives State Grid also has international investments. There are overseas investments achieved $19.5 billion, and overseas equity capital over $60 billion. And to the export of equipment from 2014 to 2017, it achieved $2.5 billion US. State Grid also attaches great importance in scientific and technological innovation. SGCC won many national science and technical awards. It contains 2 top-level prizes, 7 first-level prizes, and 60 second-level prizes. And the DC transmission technology is one of the top-level prizes. By now, SGCC has established over offices of all branches in more than 20 countries and regions, including Ethiopia, Brazil, Pakistan, Egypt, Turkey, and LVDC, and expanded its power transmission and conversion business to nearly 40 countries in Asia and Africa and Latin America. SGCC is committed to electrification and energy connectivity, meeting the power demand with clean and green energy alternatives. At present time, SGCC is facing some situations, such as the adjustment of electricity tariffs, the reform of electrical power system, the opening electrical power market, and the government calls for 10% reduction in electricity prices. These factors brings the pressure to operation of SGCC. Affected by economy and social reform, the administration of SGCC needs to be changed tremendously, so that the chairman of our SGCC, Mr. Ko, proposed the three-function, two-network strategy to transfer a traditional electricity seller to an energy internet enterprise. What's the meaning of three-function? Three-function refers to an enterprise with interconnection, platformization, and sharing characteristics. Energy internet is a typical industry internet of things, with a grid as a network hub connecting energy production and energy consumption. And what's the meaning of the ubiquitous true network? True network refers to strong smart grid and ubiquitous Internet of Things. The true network strategy is an effective way to break up the bottleneck of the current traditional power industry. With a deep integration of artificial intelligence, communications, big data, ubiquitous power network is a necessary link for a strong smart grid to upgrade to an energy internet. I think the concept is similar to the smart community. Now let's go to the second part. I will introduce HVDC project in China. HVDC transmission system have widely applied in China due to its advantage in large capacity, long distance transmission and non-synchronous network connection, while the hydropower is in the middle of China and the coal-fired fossil materials in the west of China. So the power generation is concentrated in the west and in the north of China, and the power consumption is mainly in the east of China. So that there are over 10 HVDC transmission lines in China. And the red line is the first one. The first one transmission is transfer Jiangsu River hydropower to Shanghai. The installed capacity is 6,400 megawatts. The LCC HVDC structure contains three parts: the rectifier station, the DC line, and the inverter station. And the rectifier station mainly in the power production side, and the inverter station mainly in the power consumption side. The maximum ultra HVDC transmission in China is up to 10 billion watts. That is Ximen to Taizhou, which is from Mongolia to Jiangsu. The voltage level is plus minus 800 kilovolt. The heart of the ultra HVDC project is converter valve. The rated current is achieved 6,250 amperes. This is an aerial view of Shanghai Fengxian converter station, and the land occupation is over 70.5 hectares. Although LCC HVDC is by the attention of power industry because of the unique advantages in long distance, large capacity transmission. However, there's also some defects, such as commutation failure, which is one of the most common failure for LCC HVDC transmission systems when the fault current, when the fault happened in the power grid. Another is non-linearity. The converters yield harmonic voltage and currents because it's non-linearity. And the second is absorbing large reactive power, mostly 40% to 60% of the rated power, so that the passive filters and reactive power compensators occupies large area. With the development of power electronics technology, flexible DC transmission based on voltage-sourced converters is proposed. Compared with LCC HVDC, VNC HVDC is an advanced one. The IGBT is mainly used without harmonic and reactive power compensation problems. It can be widely used in such fields such as interconnection between non-synchronous AC system, urban power supply, interconnection of islands, and the black start of power grid. The converter's valve is the core equipment, and the converter valve MMC topology is mainly used in the VSC HVDC systems. The converter valve is constructed by sub-module, valve section, and valve hull, and finder valve hull. Sub-module is a fundamental unit, which is also contains 2 IGBTs, 2 diodes, and 1 large capacitors. Here I will introduce 2 demonstration projects. The one is Zhoushan VSC HVDC project. And Zhoushan VSC HVDC project is the first 5 ports HVSC HVDC transmission project. They are Zhoushan, Daishan, Qushan, Sijiao, Yangshan, 5 islands. And Zhoushan is the biggest one. The DC voltage of the project up to plus minus 200 kilowatt. And each converter station is connected by a submarine cable. The total submarine cable achieved 140 kilometers, and the total capacity achieved 1,000 megawatts. The next project I will introduce about Zhangbei VSC HVDC project. Zhangbei VSC HVDC is the world's first 500 kilowatt HVDC system. And the level compared with Zhoushan project, the voltage level is higher, up to 500 kilowatt. There are Beijing, Zhangbei, Zhangbao, Fenning, 4 stations. Zhangbei and Fenning is a new energy center, which there's many wind farms, and Beijing is a power consumption center. Zhangbei is also the host place of the 2022 Beijing Olympic Winter Games. And it is planned that all of the Beijing Olympic Stadium will provide by 100% clean energy, and it will be a low-carbon Olympic. And now we go to part 3. I will introduce the motivation of medium voltage DC and low voltage DC. At present, HVDC used in high voltage transmission and DC voltage inverting to low-level AC voltage, and then AC voltage distributed to power to each user. With a growing number of devices generating and using direct current, there comes big opportunity for DC network to save energy. In the future, the DC distribution network and DC power consumption of users will be the trend. The MIT Technology Review gives a brief business impact on April 24 in 2012. The title is Edison's Revenge, the Rise of DC Power. In a world of more and more electronics and solar power, there's less and less need for AC power. Thanks to the growing power consumption by digital devices of all kinds, digital power is making a comeback. This time is on its own merits. Anything that uses transistors relies on direct current. The medium voltage DC can be used in application scenarios such as offshore wind power, railway transportation, ship shore power, and distribution network. And low voltage DC can be widely used in LED lighting, PCs, TVs, EV chargers, PV inverters, and data centers. By distributing DC power to DC devices instead of inverting to AC along the way, it can avoid substantial energy loss and that occur every time that electricity is converted. Now let's go to the fourth part, the MVOC and the LVDC projects in China. Here I listed 4 demonstration projects in Suzhou, Shenzhen, Beijing, Nanjing, respectively. At first, let me introduce about the Suzhou Renewable Energy Town in Tongli. Tongli Comprehensive Energy A service center contains multiple type distribution renewable energy sources, including photovoltaic, solar, thermal, wind generation, and DG power, total DG power up to nearly 3 megawatts, and the DC load nearly 1.2 megawatts. The DC consumption contains residential load, EV charger, DC air conditioner, and the DC data centers. This slide gives the electrical diagram about Suzhou Energy Town. There are two power electronics transformers transfer voltage from to transfer energy from 10 kilovolt AC line to the one is 750 volt DC, another is 375 volt DC, and another is 380 volt AC. Use these two power electronics transformers. And the project is supported by National Key Research Project, SGCC Hybrid Renewable Energy Technology based on power electronics transformer, which is supported from 2017 to 2020. And now I'll give the topology about the power electronics transformer. The power electronic transformer uses the module door active bridge with high frequency isolation. We have constructed two types of power electronics transformer. The one is a silicon IGBT-based power electronics transformer, and the other is a silicon carbon-based PET. And we tested the efficiency about these two types of power electronics transformer. And the silicon-based one, the efficiency, the highest efficiency in rapid operation is 96.5%. And the silicon carbon-based one is 1980.5% with 2.1% higher. Because it is a low switching loss, the silicon carbon-based PET holds higher efficiency. Another DC equipment is a fault current limiter. Is another DC equipment which can limit fault current by series connection to power grid. It is assembled between different buses. The electrical equipment can be so that the electrical equipment can be protected on abnormal conditions. Here I give some waveforms about the operation of the Suzhou Energy Town. The left one is the PET active power waveforms, and the 750 volt port current waveform under different operation conditions. And the right one is a photo experiment. And when we do a photo experiment, the photo current achieved 2,100 amperes, which is occurred by capacity discharges process. Because of large capacitors is paralleled at the DC bus. When a photo happened, the discharge process of the capacitor caused a large inrush current, which is seen here about 2,100 amperes. So that DC breakers is very important in DC power grid. The second demonstration project is Shenzhen Low Carbon Building. And the Shenzhen Low Carbon Building, which is also the senior US Low Carbon Building and the Community Innovation Experiment Center, it is established by Chinese and American. This gives a diagram of the electrical circuit. This building is supplied by 380 volt AC, and it is rectified into 375 volt DC, and it is distributed to other DC equipments. Here gives some regular. Here gives the table list of the DC equipment. It contains LED lighting, 48 volt socket, 375 volt socket, and EV chargers. And the total power of the positive 375 volt bus achieved about 50 kilowatt, and the negative bus achieved 80 kilowatt, and the DC conditioner is connected to the 750 watt bus. It is also there's also defined 3 areas. The one area is the regular contact area in the building, and another area, the daily activity area in the building, which means the regular contact area, it is defined as a vertical less than 2 meters with low power, high frequency use of electrical appliance and power less than 100 watt. And it is also needed to hot plug support, which can be used the 48 volt socket. And the daily activity area, the vertical is more than 2 meters. The medium power, less plugging frequency of electrical appliance, and it is need to compatible to line frequency AC equipment. The public area is defined as professional operation and maintenance, such as air conditioner and high power DC equipment with low contact frequency. This definition, the advantage of this definition is that it is very safe. The electrical system is very safe for children, which is usually contact in the regular contact areas, so that we can use 48 volt socket in the vertical less than 2 meters. And now I will introduce a third demonstration project, which is in Beijing and Xiaode flexible substations. And Beijing Xiaode substations, it is also a four-port power electronics transformer. Compared with the Suzhou power electronics transformer, Xiaode power transformer has the medium DC voltage port, the 10 kilovolt DC port. The topology of flexible substations also use the MMC circuit. The power consumption load contains Zhangbei Alibaba data center. Now, fourthly, I will introduce all LVDC building, which is constructed by Golden Corporation in Nanjing. The whole building is operated on the 2 buses. The one is 600 volt DC bus, and another is 220 DC bus. And the company is nearby to our company, so we tested some power qualities about the LVDC system. We recorded 24 hours as an operation cycle and analyzed the 95% probability large value about the harmonics and 99% probability value of the harmonics. And as we analyzed the 300 hertz and 600 hertz is the main harmonic in the LVDC system. It is because it is influenced by a line frequency rectifier. We also analyzed the bus voltage quality. The voltage variation range is below 0.5. Is below 0.5 volt when air conditions turn on and off. Now let's go to the 5th part, the standardizations about activities. Here I will introduce our IC, Technical Committee 8, Workgroup 9. Workgroup is established in Vladivostok, Russia, IEC Technical Committee 8, Workgroup 9, called experts together to delegate the standardization work of LVDC system. And on May 2018, we participated in the general meeting of System Committee LVDC meeting and made a presentation about the low voltage level and peak phenomena in low voltage DC distribution systems. And on May 11th to on May 13th, we hold a kickoff meeting in Nanjing, joint kickoff meeting together with the System Committee LVDC. And on October 16 to 17, 2018 IEC Technical Committee 8 Work Group 9, the work group meeting in Busan established the joint working group and JWG9 managed by Technical Committee 8. And in January 27th to February 1st, in 2019, IEC System Committee joint annual meeting was convened together in Switzerland. According to the System Committee, LVDC and the Technical Committee, Work Group 9 is mainly devoted to LVDC distribution networks. And the IEC technical report, standard voltage and power quality requirements for LVDC is the first task. It is our first task. And it will be the basis of a series of standards such as following-up planning, such as protection control and operation management. IEC had always paid high attention to developments of LVDC. System Committee, LVDC, and the Technical Committee 8 both actively take part in the standardization of the LVDC. And my boss is the convener of Technical Committee 8, Work Group 9, which is many standardization activities we are incorporated with System Committee LVDC. Here, let's go to the last part. I will give some incorporation suggestion. Firstly, the standard of LVDC level have not yet been unified. Japan and Chinese research organizations can establish DC level and power quality standard together to promote DC network and promoting practical process of DC power grid, such as intelligence home, DC building, low voltage DC interface, coordination, operation of new energy access. And secondly, compared with traditional AC power system, the DC grid is full of power electronics devices, and the stability mechanism of DC grid is not clear yet. China and Japan can enhance exchange and cooperation between academics, analyze the stability of DC network, investigate the DC arc separation technology. And at last, thirdly, Sino-Japanese cooperate to build DC demonstration, joined together to develop new products and promote application of DC devices. That's the end of my speech. Thanks for your attention.
Thank you very much, Dr. Shi. We'd like to take some questions. The first question. Today, we talked about HVDC to LVDC. And in China, are you trying to introduce the DC transmission for all the grids in the entire nation? Is this a goal?
We have tried to experiment of all voltage level DC power grid, and we have to analyze about the efficiency, compare the efficiency to AC systems with the DC systems, so that we tried to study all of the voltage level DC transmission and distribution systems.
Thank you very much. Next question. Also, in China, HVDC and LVDC, which part are you going to focus? Which part do you think China will focus on? Low or medium or high?
China has done many tasks on high voltage DC transmission systems. And China is a large country, and China has utilizing the eastern fossil materials to power the east of China power consumptions. So that the HVDC systems is very important part to China. And besides the LVDC system, China is a large power consumption country. so that LVDC system has higher efficiency compared to AC system. So that I think that LVDC systems will be another important part compared to AC systems. And the medium voltage DC, I think it also has ways to go because of the large because of the expensive of the converters in DC power electronics converters. The medium voltage DC power converter is more expensive than traditional AC transformers.
ありがとうございました。それでは、
Thank you very much. The last question. You talked about the self-excitation or the non-self-excitation. So what do you think about the black start? Have you ever conducted black start?
Black start we have not facing the black start situations, and we have not done black start of the power grid, and our power grid is so strong. But I have done the isolation that is called the isolation of the power grid. We have done, yes, in low voltage DC. In low voltage DC system, we have done isolated power grid.
ありがとうございました。では、
Thank you very much. With this, we'd like to close this session. Please give him a big hand. Dr. C, thank you very much.